Hello everyone. Welcome to the YouTube channel Yugandhara Tarele. Today we will dwell into the fascinating concept of the center of gravity of line elements. Have you ever wondered how engineers determine the balance and stability of various structures like bridges, rods, columns? It all comes to the simple concept of center of gravity. Center of gravity is the critical concept of the structures determining the stability, safety, and balance of the various structures. In this video, we will see the practical demonstration of how to calculate center of gravity of line element and also the mathematical way of calculating the center of gravity of line element. So, whether you are an engineer designing the very complex structure, or if you are curious about day to day structures and the physics behind it, let's watch this video and study the concept of CG of line elements with me. Join me into the fascinating journey of learning the physics behind the center of gravity of line elements. Don't forget to like and share the video with your fellow classmates or colleagues and subscribe for more such videos. So let's get started. Engineering Fundamentals by Yugandhara Tarale. So, we are studying different concepts related to columns. The list is this. Examples on center of gravity. Center of gravity is the geometric center at which whole weight of the body is assumed to be concentrated. So, for an uniform rod which has uniform density, its geometric center is exactly equal to its center of gravity. So, for practical demonstration purpose, let's consider this stick. Is it uniform? See its cross section. It is uniform throughout. So it has uniform density. So let's find out its length. Let's use tape and its length. How much is it? It is less than a feet. 11.7. Now for this rod, we will mark its midpoint. We have its center. At this, is it really a midpoint? Can you verify that? Okay. So, at this point, I will try to balance this rod. Ooh, see, it's really like a magic. This rod is balanced on that single point, which is midpoint, and now we can conclude it is also the center of gravity. Center of gravity is very essential for determining the stability and equilibrium of the structures. So the concepts for examples on line elements. Some basics. So what is that structure which has assembly of line elements? Yes, it is truss. And if the cross-section area is constant, we consider length for calculating CG. Otherwise, we consider volume. If volume of line member we want to calculate, it is calculated by this. Cross-sectional area is multiplied by its length. For this type of problems also, we will follow particular steps. So, those steps are: first, we decide the reference system. That is, we fix the origin and consider x and y axis passing through that origin. Then we divide given figure into basic components, basic geometric shapes, for which we already know center of gravity. Then we do calculations according to this table. In that, serial number of the element, name element, what is the length of the element? X. X is the CG of that element, x coordinate of CG of that element. Similarly, y is the y coordinate of CG of that element. Then the product L into x and L into y. And finally, the summation of length, summation of L into x and summation of L into y is calculated. Then for line elements, we take CG of complete geometric shape is summation of L into x divided by summation of L. And for y coordinate of CG of that complete line skeleton is summation of L into y divided by summation of L. So now we will see the problem statement. This is the line element skeleton for which we have to find out its center of gravity. See, it is in the shape of 5. Element AB, AC and chord CD, which has radius of 50 unit, and the C and D are in the same line, and 90-degree angle is subtended at the radius of OC and OD. So the first step is reference system. So let's fix the origin at A, and x-axis is passing through element AB and y-axis is downward passing through element AC. Now, what is the next step? Yes, we will divide given figure into basic components. So, yes, this is the first element AB, this is the second element AC, and this is the chord CD. We are ready to go next step. For next step, yes, we have to do the calculations according to the table. See, this is that table. So for that, we will separate out all the elements one by one and do the calculations. So let's separate out element AB first. So this is element AB with all its dimensions and its location. Yes. Now element 1, its designation is AB, its length is 80. Yes. Now we want X. What is X? X is the CG of element AB. X coordinate of CG of element AB. So this yellow circle is the CG of the AB and it is at a distance of 40 units from the origin. So what is X? It is 80 by 2. Correct. 40. And what is Y for AB? It is 0 because the x-axis is passing through element AB. Now, come on fast. Let's do the calculation Lx and Ly. Now, we have the calculation of element AB. Let's take second element AC. Let's separate it out. This is the element AC. Can you see? With all its dimensions, with its perfect location. Mark that in the table. Serial number 2, element AC, length is 50 units. And now the coordinates of CG of element AC. What are those? It is 0 because AC is passing through the y-axis. Can you see? And what is y? Correct. It is 25. And the product Lx and Ly. Now, in the next step, we want to separate out the CD. Oh, its shape is quite irregular. Let's solve it together. Element 3, its arc CD. What is the length of arc CD? Let's apply some geometry. So, we have separated out this arc CD. What we want? We want the angle subtended at the center O by the arc CD. Okay? We already know this OC and OD are perpendicular to each other. So, this complete 360 degree minus 90 degree, we have 270 degrees. So, angle subtended at the center by arc CD is 270 degrees. Now, you know, the length of arc CD is r phi, where phi is in radians. Let's calculate. 50 into 270 degrees converted into radians by multiplying pi by 180. So we got length of arc CD as 235.61 mm. Now we want this x bar, that is the CG of x coordinate of this arc. So it has this formula, r sine alpha upon alpha. But what is this alpha? Let's see. This is the axis of symmetry for arc CD. And we know this angle is 90 degree. So this yellow marked angle is 45 degrees. And what is alpha? This is alpha. From axis of symmetry to the radius OC. So alpha is equal to this 180 degree minus 45, which is equal to 135 degrees. Now x bar is r sine alpha upon alpha. We know alpha is 135 degrees. So come on fast, do the calculations. 50 sine of 135 divided by this alpha is in radians, so 135 into pi by 180, which is equal to 15 mm. Now back to the table. We know length. See, we have separated the arc. We know length. We already calculated it to 235.61. What is x? For that, let's mark here CG. Let me have the highlighter or pen. Okay, pen. So, this is here the triangle and we want distance from this y-axis. So, which is equal to 50 cos of 45 degree. So, x coordinate of CG of this arc CD is 50 cos of 45 plus x bar, which is 15. Similarly, how to calculate y? Here also we have to calculate this OC and then plus this 50 mm. Correct. See in the figure, it is equal to 50 plus 50 into sine of 45. Now we have all the necessary calculations. So L into X and L into Y. So for this given linear elements, we have the calculation for all the elements. Let's take summation. Summation of L, which is equal to 365.61. Next, we want summation of the product L into X and summation of the product L into Y. Now we are ready to go. Let's apply the formula. For thin homogeneous wire, X bar and Y bar are calculated like this, where L, XY and X bar are designated for these things. L is the length of components. X and Y are the coordinates of CG of components. X bar and Y bar are the coordinates of CG of complete body. So for this given problem statement, we got X bar and Y bar as like this. So let's show that into the given figure. See, from origin, the coordinate of CG of this complete linear element is 41.20, and from origin it is on the y-axis it is 58.42. So this is the CG of this line element. Thank you so much to you all for being with me throughout this video. We will learn many more concepts in the subsequent videos. Till then, bye bye and happy learning. Find this video useful, then please share. It will help others, and subscribe to get notified about the new videos.